Hi, I'm going to explain the workflow to get proper ground control points on the ground for the auto-rectifying of orthographic imagery. So as you can see, this is the available map data. So there are some random polygons supposedly representing buildings. Then you have a larger polygon which defines residential area. And outside of that is wood. Now the thing is, if you want to put a ground control point here, you have no idea where you're going to put it and if that's actually even a good location. So if you go to satellite data, this is from Bing, then well, you see what appears to be a shed or a building, a structure of some kind there. That's basically where these polygons come from. You have no idea, is that really a building where people live? Is that a shed? Is it maybe even some greenhouse? It's hard to figure out. Either way, how are you going to know where to put a ground control point here? So that's why I flew the drone over it at very high elevation. It is not ortho-rectified because I don't have the ground control point yet. And it's not high detailed. So it's neither accurate nor detailed, but I can show you the difference. Look at this. This is satellite. So we disable here the Bing, and then we say we want this image. So this is with the drone from very high elevation. So I can zoom out. You can see how high I was. And then let's zoom in. Right. And now I can determine where I want the ground control point. What is a good location? Where can I go? And then, because I cannot use a fixed ground control point there, it's all dirt. But I can put this on the ground. I measure exactly the center point of the X. And then with the numbers, I put also numbers there. So it gets a proper number. So I can always identify that specific ground control point. I measure it with the RTK. Then I fly with the drone over it. Once the drone is back down, once I got 10, 15 shots, that's more than enough. I can pack everything up and goes to the next. So using this drone image from a high area, it's not detailed, it's not accurate, but it gives me a good indication. Then I say, for example, okay, I don't want to fly too close to the house. People might be worried or afraid or whatever. So it's important always keep your distance. So this is roughly 15 to 20 meters distance. So that's a good location. But it doesn't change the fact that I determine on orthographic imagery that's a good location. Now the next question is, how do I get there? Because let's disable this again. Let's open the map data. This is the map data. It doesn't tell you how you get from there to there. And 200 meters can be a lot of walking back and forth and figuring out how to get there. So instead, you start mapping to make sure that you know how to get there. Now in mapping, this is the same location. This is a different app, so that was QGIS, but this is JOSM. JOSM allows me to map. So in JOSM, I can see there's a footway here, and I can literally map that footway. Right? And here it's under the tree, so where it's going? Well, here I can see again it's continuing. And here's again, where is it going? Well, it's either going here and connects there, or it's going straight in this connection. Now that doesn't actually really matter once I'm there on the ground. Once I know there's a path somewhere there, that's good enough. So I'm just going to connect it here at the top of those steps here. So the steps start there and go down, but at the top of the steps, that's good enough. Assume there's a path going to the right. Then I add the survey data. So the geometry, the survey data was from May 2026. And then I say, that is a path, and I say the surface is dirt. That's good enough. Now I know how I can get from this part to here. So it takes 2 to 3 days for the map to be updated. But then once it's updated in a couple of days, sometimes even within 24 hours, I can simply use my phone. I go there, I park the motorcycle. I can park the motorcycle here on the road, and my phone will tell me then, here you go up to the right, or to the left, whatever. Here you go up the steps to the right then. Now you go left. Now you follow the footway. And here you go to the right. And you follow the footway. Et voila, I'm at that point. So before, I wouldn't have a clue. But because I took the time, which is about 6 hours it took me to do 5 square kilometers like this over Baguio. So basically you can do Baguio in 2 weeks if you fly very high. It's not accurate. It's not highly detailed, but it's good enough for these kinds of tasks. Then you process that data, you use it to map the data, you use it to determine where you can put the ground control points, and then you have your data ready to do your flight mission planning and to actually conduct the final flight, which is on 40, 50, 60 meters roughly. That gives you then the level of detail of 1 centimeter per pixel and the accuracy of 1, 2, 3 centimeters in PRS 92 zone 2, zone 3. Yeah, and that's basically the workflow.